Thermal diffusivity measures how fast heat diffuses through a material. It is defined as a ratio of material thermal conductivity to material heat storage. Its symbolic expression is as illustrated. A material with high thermal conductivity or a low heat capacity will have a relatively large thermal diffusivity. The larger the thermal diffusivity, the faster heat propagation into the medium. A small thermal diffusivity value means that the material mainly absorbs heat, and a small amount of heat is conducted further. Convection is the mode of energy transfer between a solid surface and the adjacent liquid or gas that is in motion. It involves the combined effects of conduction and fluid motion. The faster the fluid motion, the greater the convection heat transfer rate. In the absence of any bulk fluid motion, heat transfer between a solid surface and the adjacent fluid is by pure conduction. The rate of convection heat transfer can be determined using the rate equation based on Newton's law of cooling. Newton's law of cooling states that the heat transfer rate by convection is proportional to the surface area and temperature difference between the surface and bulk fluid. Its symbolic expression is illustrated here. H is convection heat transfer coefficient with a unit of watt per square meter per degrees Celsius. A subscript S is the surface area through which convection heat transfer takes place. T subscript S is the surface temperature, and T subscript infinity represents the temperature of the fluid sufficiently far from the surface. Forced convection is categorized when the fluid is forced to flow over the surface by external means like a fan, pump, or wind. While Natural convection is when the fluid motion is caused by buoyancy forces induced by density differences due to the variation of temperature in the fluid. Heat transfer processes that involve a fluid phase change are also considered convection because of the fluid motion induced during the process, such as the rise of the vapor bubbles during boiling or the fall of the liquid droplets during condensation. The convection heat transfer coefficient H is not a fluid property. It is an experimentally determined parameter whose value depends on variables such as the surface geometry, the nature of fluid motion, the properties of the fluid, and the bulk fluid velocity. Typical values of convective heat transfer coefficients are presented. The values range from free convection to boiling modes.